In this lesson, we are going to go over the midpoint and distance formula. Make sure you have your calculator, the one that you're able to use with you, as we will use it quite a bit in this section. So as I mentioned, we're going to talk about distance and midpoint formula, but before we do that, we have to take a side detour to learn to simplify square roots. And then we're going to understand how to calculate the distance between 2 points on a coordinate plane. And then we'll do that, and we'll also learn how to calculate the midpoint of 2 points on a coordinate plane. Okay, so to start off, square roots. So example, we have the square root of 25. Okay, so the square root of 25, when we're evaluating that, we're looking for what number times itself is going to give us 25. Okay, so you might say that that's 5, because 5 times 5 is 25. So 5 is the square root of 25. And this is because... Okay, one thing to note is this symbol here is called a radical symbol. You might see that during the lesson and maybe in some of the homework assignments as well. But what we're going to do is we are going to learn to simplify square roots that are not perfect squares to where we will still have a radical as part of our answer. Okay, so with simplifying radicals, you can use perfect square factors or prime factorization to simplify the radical to get an exact answer. And then we're also going to use our calculator to find the answer rounded to 3 decimal places. So for this first one, I'm going to show you how to do it both ways. And for the next one, I'll pick one way. And for the next one, I'll pick another way. Okay, so first, perfect square factors. So I'm going to write out the factors of 24. I always start with 1. That's just the way my brain organizes it. 2 times 12, 3 times 8, 4 times 6. And I'm going to look at this list of factors to see which one or ones has a perfect square. And that would be 4 times 6. 4 is a perfect square because 2 times 2 is 4. So then what we can do is rewrite this as the square root of 4 times 6. Remember, 4 times 6 is 24. And we can break this up. Okay, the square root of 4 is 2, and this is still being multiplied by a radical or square root of 6. Okay, so the final answer here is 2 square root of 6. I'm going to go to the other way to do it by using prime factorization. And so if you're using prime factorization, we are going to break down 24 into its prime factors. And now prime factors have no other numbers that divide into them besides 1 in itself. Okay, so 2 and 20 and 12. 12 can break down into 4 and 3, and 4 breaks down into 2 and 2. So my factors are 2, 2, 2, and 3. Okay, so now I'm going to rewrite the radical as 2 times 2 times 2 times 3. And we look for pairs since we're looking at square roots. There's a pair of 2's here, so 1 will come on the outside. So this is 2, radical 2 times 3, which is the same thing as saying 2 square root of 6. Okay, so either way you go, you'll get the same answer. As I mentioned for this first one, I wanted to do it both ways, and then I have a couple of other examples. When we talk about putting it into our calculator, I want to suggest a couple of things. First, put in the original problem into your calculator, and second, since you had to give an exact answer, also put in 2 radical 6 and make sure they match. Okay, so on your calculator, you might have to find the radical button. Mine happens to be in a grayed out above a button. So to access anything, any of the small writing above buttons, you have to hit second, and then you can type in 24. Okay, so this is going to give me, let me do this on the next slide actually. This gives me equals 4.89897 and so on. And we're rounding to 3 decimal places. So the third decimal is 1, 2, 3. We look next door. If the number next to it is 5 or higher, it causes the number in the third decimal position to go up 1. Okay, so since it's a 9 right next to it, the 8 is going to go up 1 to a 9. And then also, if you put 2 radical 6 in your calculator, you would put it in as 2 times the square root of 6. When those are next to each other, it means multiplication. And we would get the same answer. Okay, for the next example, I'm just going to use perfect square factors, and the one after that I'll use prime factorization. So for square root of 54, I'm going to write down all of my factors. 2 times 27, 3 times 18, 6 times 9. Okay, so the one that has a perfect square is my 9. So I'm going to write this as 6 times square root of 9. And we keep going. We can break it up. And now notice I purposely wrote the 9 second, so this becomes square root of 6 times 3. I would reverse the order of that. If your square root were to continue over that 3, it would not be correct. The 3 is a number on its own outside of the radical square root of 6. Okay, and then we plug this into our calculator. And we get 7.34846 ... and we're rounding to 3 decimal places. So we look at the third decimal. The number next to it is a 4, so it's not 5 or greater, which means that this will stay the same. Okay, for the next example, square root of 125. So here I'm going to use prime factors. So 125, numbers that end in 5 are divisible by 5, so I would take 125 and divide it by 5. So we have 5 times 25, and then we have 5 and 5. Okay, so we rewrite this as the square root of 5 times 5 times 5. We have a pair of 5, so 1 comes out, and the other stays in to give us 5 times the square root of 5, or 5 radical 5. Okay, and then we put this into our calculator. Okay, and then we get 11.1803 ... We're rounding to 3 decimal places. The number next to it is a 3, so it means that the 0 stays the same. However, the system is going to be looking for 3 decimal places, so that 0 does need to be there in my lab. Okay, so what we'll do, that was a refresher of simplifying radicals, or maybe you learned it for the first time. Either way is okay. And then in the next lesson, we'll continue on distance and midpoint.